No cable, no phone tower, no neighbor, no signal. Kirac is standing in the middle of nowhere. Then he places one flat white dish on the ground. Satellite races overhead, then another, and suddenly, internet. But those satellites are moving at thousands of kilometers per hour. The dish barely moves, and Elon Musk somehow expects the whole thing to keep Kirac's video call alive. So how does Starlink actually work? First, Starlink does not create the internet. There is no tiny internet factory inside the dish. The dish is simply one entrance into a much larger network. When Kirac opens a website, his laptop sends a request through Wi-Fi to the Starlink router. The router passes it to the Starlink terminal. The terminal converts the data into a radio signal and sends it toward a satellite above Earth. The satellite then moves the request through the Starlink network until it reaches a connection to the ordinary internet. From there, the request travels to the server holding the website, message, or extremely important cat video. The answer returns through the same general chain: internet, ground network, satellite, dish router, laptop. So Starlink is not a separate internet. It is a way of reaching the ordinary internet through space instead of through a cable running all the way to your home. It sounds complicated, but the whole journey begins before Kirac has time to complain that the page is loading slowly, which is impressive. Kirac complains very quickly. Satellite internet existed long before Starlink. Traditional systems often used geostationary satellites, roughly 786 kilometers above Earth. From the ground, they appear to remain in almost the same place. That makes the antenna easy to aim. Point it once, leave it there. Try not to let a tree grow in front of it. But every request must travel tens of thousands of kilometers up and back. Then the answer repeats the journey. That delay is called latency. Speed tells you how much data can move. Latency tells you how long the trip takes. Starlink reduces that distance. Instead of depending on a few satellites very far away, it uses thousands of satellites in low Earth orbit. Many operate at altitudes around 550 kilometers. That is still space. But compared with 786 kilometers, it is practically upstairs. The shorter route can greatly reduce latency. That is why Starlink can handle video calls, gaming, and normal web browsing much better than older satellite systems. Low orbit solves the distance problem. Then it creates another one. A satellite only a few hundred kilometers above Earth cannot remain over Kirac's house. It races across the sky at several kilometers per second. One satellite appears. It crosses the visible sky. Then it disappears. If Starlink used only one satellite, Kirac would have internet for a few minutes. Then he would wait till tomorrow. So SpaceX uses a moving constellation of thousands of satellites. As one satellite leaves range, another takes over. This is called a handover. Mobile phones do something similar when they move from one cell tower to another. Starlink performs the same basic trick, except the towers are flying through space. The network predicts satellite positions, checks signal quality, and selects the next connection. The user usually notices nothing. One satellite leaves. Another takes over. The video continues. Civilization survives. Low latency requires low altitude. Low altitude causes movement. Movement requires a constellation. Now comes the clever part. How does a flat dish follow satellites, moving rapidly across the sky? Kirac could stand on the roof and turn it by hand, but the satellite would disappear before he found the correct screwdriver. Starlink uses a phased array antenna. Instead of one simple antenna element, the terminal contains many small elements working together. The system controls the timing of the radio waves they produce. When those waves combine, they reinforce one another more strongly in a chosen direction. By changing the timing, the antenna changes the direction of the radio beam electronically. The dish does not need to physically swing from satellite to satellite every few seconds. The beam moves even when the terminal appears almost still. Imagine several people making waves in a pool. With carefully controlled timing, their waves reinforce one another in a chosen direction. A phased array does something similar with electromagnetic waves. This lets the terminal switch between moving satellites without becoming a spinning rooftop fan. Reaching the satellite is only the first half of the journey. The satellite still needs a route into the ordinary internet. One option is a ground station, also called a gateway. The satellite receives Kirac's request and sends it down to a Starlink ground station. That station connects to terrestrial fiber networks and other internet infrastructure. From there, the request travels to the correct server. But what happens over an ocean or far from a suitable ground station? Modern Starlink satellites can communicate directly with one another using optical intersatellite links. In normal language, space lasers. These lasers carry data between satellites. A request can move across several spacecraft before returning to Earth closer to a useful ground connection. This creates a mesh in space. There is no cable between the satellites, no tower, no unlucky worker pulling fiber across the Atlantic. Just precisely aimed light, moving between machines that are also moving at enormous speed. The lasers are carrying data, not shooting cities. Elon Musk did not build a giant space weapon just so Kirac could stream a cooking video. At least, not this time. Let us follow one request from beginning to end. Kirac clicks on a video. His laptop sends data to the router. The router passes it to the Starlink terminal. The phased array antenna forms a focused radio beam toward an available satellite. The satellite receives the request. It may send the data directly to a ground station, or it may pass it through other satellites using optical links. Eventually, the request enters the terrestrial internet. Ground routers guide it from network to network until it reaches the server holding the video. The server sends data back. The return route may be different because the network chooses from the connections available. The video arrives in many small data packets. Kirac's device checks them, arranges them, and begins playback. This continues every second while satellites move and routes change. And Kirac still asks why the picture became blurry for half a second. Starlink uses rockets, thousands of satellites, phased array antennas, automated routing, and space lasers. Its most dangerous enemy is a tree. The terminal needs a broad and reasonably clear view of the sky. Because satellites move, the dish must communicate through different parts of that sky. A branch may not block the active satellite now. 30 seconds later, the next satellite may pass directly behind it. The system can try another satellite. But if a useful path is blocked, the connection can drop. Buildings, roofs, poles, and cliffs can cause the same problem. The Starlink app therefore helps users check for obstructions. Heavy rain can weaken the signal, and snow can cover the terminal. Starlink dishes include a snow melt function, so the dish can talk to space and warm itself. Kirac's toaster can only do one of those things. The system is advanced. The laws of physics remain employed. Does all of this make Starlink better than fiber? Number, not automatically. Fiber sends information as light through a physical cable. A good fiber connection can offer very high capacity, stable performance, and very low latency. Where reliable fiber already exists, it will often be the better connection. Space is impressive. A cable can still win, but someone must install fiber. That means trenches, poles, permits, maintenance, and money. In a city, one cable serves many customers. On a mountain, island, farm, or ship, the cost becomes harder to justify. Starlink changes the final connection. The user installs the power terminal with a clear view of the sky. The network is already passing overhead. That is Starlink's real strength. It does not make fiber obsolete. It brings useful broadband to places where good terrestrial infrastructure is unavailable, damaged, or impractical. Fiber usually wins where the cable reaches you. Starlink becomes powerful where the cable stops. Building Starlink requires more than satellites. It must be launched, tracked, maneuvered, replaced, and eventually removed from orbit. SpaceX has an unusual advantage because it builds both the Starlink satellites and the rockets that launch them. Reusable Falcon 9 rockets help make repeated launches more practical. That is one reason Elon Musk's company can keep expanding the constellation. But thousands of satellites also create responsibilities. Operators must reduce collision risks and prevent failed spacecraft from becoming debris. Astronomers have also raised concerns about bright satellite trails affecting the night sky. Starlink is impressive engineering. That does not mean every consequence should be ignored. So what is Starlink really? It is not one satellite. It is not one dish. And it is not internet stored in space. It is a coordinated system made from many moving parts. Low Earth orbit reduces signal distance. Thousands of satellites maintain coverage as individual spacecraft move away. Phased array antennas steer radio beams electronically. Handovers transfer the connection from one satellite to another. Hand stations connect a constellation to terrestrial networks. Optical links move data between satellites using lasers, and internet protocols guide the information toward the correct server. The user sees one small dish. Behind it is a network moving around the entire planet. Kirac clicks. The router sends. The dish aims. The satellite receives. The lasers relay. The ground network routes. The server answers, and the result returns before Kirac finishes asking, "Is the internet working?" That is how Starlink works. It does not replace the internet. It builds a moving road to it through space. And now Kirac finally has broadband in the middle of nowhere. Unfortunately, he has also discovered online shopping. The next satellite may already be carrying his order.